Good morning, students. I am Tigy, HOD, Physics Department, Ahmadiyya International School, Mali, Maldives. Today, we are going to discuss about the topic static electricity. We all know that electricity is something which plays an important role in our life. We cannot think a day, at least an hour, without electricity. Today we are going to discuss about the transfer of electron which is related to static electricity. We all know that all the matter is made up of atoms. Atoms are the fundamental particles in any matter. There are three types of matter that we have studied. They are solid, liquid and gas. All these are made of atoms which show all the properties of an element. In an atom, there are three types of particles which are the neutrons, protons and electrons. Neutrons does not have any charge where protons have positive charge. Electrons are negatively charged. The protons and the neutrons are inside the nucleus. So the charge of the nucleus is positive and the electrons which are negatively charged are revolving around the nucleus. Normally, when we are taking an atom, the atom is electrically neutral. What does it mean? Electrically neutral means the overall charge of an atom is zero. The total number of proton will be equal to the total number of electron. That means the total number of positive charges and the total number of negative charges are equal. They cancel each other. The third particle which is there in an atom is the neutron. The neutron does not have any charge. So when we are taking an atom, since the number of proton is equal to the number of electron, the charges cancel each other and the overall charge of an atom will be zero. The figure on the screen shows the structure of an atom. In an atom, the nucleus have neutrons and protons and the electrons are revolving around the nucleus. So there are two possible questions that can be asked from the things that we have covered till now. They are, describe the structure of atom. Why an atom is electrically neutral? The first question is, describe the structure of atom. So, when we are describing the structure of atom, we have to tell mainly about 4 points. That is, they are related to the particles, the position, the number of particles, and the charge of the particles. So, the first point is related to the particles present in an atom. Which are the particles present in an atom? Protons, neutrons, and electrons. What is the second point? It's related to the position of the particles. So when we are telling about the position of the particles, we have to tell that the neutrons and protons are inside the nucleus. The electrons are revolving around the nucleus. The third point is related to what? The third point is related to the charge of the particles. The charge of the particles means we have to tell that the protons are positively charged, the electrons are negatively charged, and the neutron does not have any charge. The fourth point is related to the total number of particles present in an atom. For that, we need to know the proton number, neutron number, and electron number. So the atomic number and the mass number is giving the number of protons, neutrons and electrons. Atomic number is basically the proton number. So in a neutral atom, the number of protons and the number of electrons will be equal. Mass number is actually the total number of protons and the total number of neutrons. So in order to find the number of neutrons, what we have to do? We have to just subtract the mass number and the atomic number. So we will get the number of neutrons. So these are the points that we have to write when we are asked about the structure of an atom. The second question is, why an atom is electrically neutral? Already we have discussed about it. So what we have to write, the 3 points that we have to write are, protons are positively charged, electrons are negatively charged. Then the total number of proton is equal to the total number of electron. Then the total number of proton and electron, they cancel each other, and the neutrons does not have any charge. So what are the points that we have to write there? Protons are positively charged, electrons have negative charge, the total number of protons and electrons are equal, the charges cancel each other, and the neutrons does not have any charge. There are two types of materials. They are conductors and insulators. Conductors are the materials which will allow the electrons to flow freely. What is this free flow of electrons? So there already we have discussed about the electrostatic force, the force of attraction between the electron and the nucleus. So this electrostatic force is very weak in conductors, and the electrons can flow very easily through the conductors. The electrons can overcome the electrostatic force and move freely. So they are known as free mobile electrons. In conductors, there are a lot of free mobile electrons which can move freely through the conductor. The examples of conductors are copper, aluminum, etc. In insulators, there are no free mobile electrons. That means the electrostatic force, the force of attraction between the electrons and the nucleus, that force is very weak in insulators. So it will not allow the electrons to flow freely. The examples for insulators are plastic, rubber, etc. Normally, there are two types of charges in an atom. Which are the two types of charges? The positive charge and the negative charge. The law of static electricity says that the like charges will repel. That means when a proton and proton come near to each other, or when a positive charge and positive charge come near to each other, they will repel each other, as well as when a negative and negative charge or an electron and another electron come near to each other, they will repel. The unlike charges will attract. That means the positive and negative charge will attract. The figure shows the positive and negative charges are attracting, as well as the positive and positive, negative and negative charges are repelling. When we are taking an object, that object will be electrically neutral. That means the overall charge of that object will be zero. So we can charge an object by two methods. The two methods are charging by friction and charging by induction. In both the cases, what we are doing is we are making the object charged by giving an electron or taking an electron. So if an object is gaining the electron, that object is becoming negatively charged, and if an object is losing an electron, that object is becoming positively charged. So by friction, what we are doing is we are providing some energy for the electron, so that electron will overcome the electrostatic force, and that electrons will be coming out of that atom, and it will be transferred from one object, and the second object with which we are rubbing it will be gaining that electron. So the first object becomes positively charged and the second object becomes negatively charged. Some examples for charging by friction is given. So in all these cases, what is happening is when the two objects are rubbed each other, one of the object is losing electron and the other is gaining electron. The one which is losing electron is positively charged and the one which is gaining electron is negatively charged. In the diagram, we can see a charged rod, a metal can, and that metal can is placed over an insulating stand. So when we are bringing the charged rod near to the metal can, the electrons are attracted towards it. The reason for it is the charged rod is positively charged, and the electrons are the only particles which can move, and there in the metal can, from one side of the metal can, the electrons are moving towards the positively charged rod. So here we are separating the charges. After separating the charges, what we have to do is we have to earth the metal can. Earthing the metal can means we have to connect the can to the ground. So we can use a conductor to connect the can to the ground, or we can just touch the metal can. So that what is happening there is the electrons are transferred from the ground to the can, and it will neutralize that positive charge. So the only charge remaining there in that metal can will be negative. So we are keeping the rod near to the can and we are earthing it. After that, we are removing the earth connection, then we are removing the rod so that the electrons which are accumulated or built up in one side will be distributed throughout the can, and the can becomes negatively charged. Electric field. So when we are taking a charge, that is a positive charge or a negative charge, there will be a region around that charge where that charge can experience a force on another charge. For example, if we are bringing a positive charge near to another positive charge, there will be a force of repulsion. There, if the charges are coming in their field only, that force will be experienced. The same way, when we are bringing a positive charge and a negative charge near to each other, if the field are interacting, there will be a force of attraction between them. So, we can define an electric field as a region around a charge where it can experience a force on another charge. Law of conservation of charges. Like that of the law of conservation of energy, what is the law of conservation of energy? Energy can neither be created nor be destroyed, but it can be transferred from one form to another. The same way, we can say about the law of conservation of charges. Charges also cannot be destroyed or created, but it can be transferred from one body to another. Electric field is the region around a charge where it can experience a force on another charge. This electric field is represented by field lines. The field lines are always from positive to negative. That means the field lines are starting from positive and ending in negative. We are drawing the field lines using lines. In that lines, there will be arrows to show the direction of the field lines. So, the arrows will be pointing from the positive towards the negative. When we are drawing the field lines should not cross each other. When the field lines are crossing each other, it shows that the field lines are cancelling each other. The strength of the electric field is represented by the number of lines. So if more number of lines are there to represent the electric field, the strength of the electric field will be more. And if the strength is weak, the number of lines will be less. On the figure you can see two parallel plates. One of the parallel plate is connected to positive and the second is connected to negative. The field lines are drawn from positive to negative with the arrowhead pointing towards the negative. So when we are drawing the field lines in between the parallel plates, we have to take care of something. The first thing that we have to take care is inside the parallel plate we have to draw the field lines which are parallel to each other. They are equally spaced, that means the distance between each line should be equal, and the lines which is representing the field outside the parallel plate should be curved. The figure shows the field pattern between a positive and negative charge. When we are drawing the field pattern between a positive and negative charge, we have to draw at least 3 lines and the arrowhead have to be from positive to negative. The first two figures shows the pattern of field between a positive and positive charge and a negative and negative charge. Only thing that we have to take care is how to draw the direction of the arrows. So in the first figure there are positive charges kept near to each other. There's a force of repulsion. The field lines are from the positive, so the arrowhead is outside towards negative. That means from positive outside. The second diagram, the field between two negative charges are given. Look at the arrow. The arrows are pointing inside. The third figure is showing the field pattern around a point charge. That means a single positive charge. There, a field is shown with an arrow outside. The next diagram shows the field around a negative charge where the field is pointed towards the charge. The arrowhead is towards the charge. In the previous lessons, we were discussing about the charges, how the charges are acting or what are the forces acting around a charge, how the field lines will be like that. Now, what are the uses of this static electricity? There are a lot of uses which are there around us. So there are a lot of applications and uses. The most important application is all of us are taking photocopy. The original document will be given and a copy of that will be taken. So actually there the photocopy machine is working with the help of the principle of static electricity. The same way the lightning conductor. You all have seen the lightning conductors above the top of tall buildings. It is to protect the buildings from lightning, the strike of lightning. Actually the lightning is a stream of electrons which is coming towards the earth or going away from the earth. That stream of electrons can actually make lot of damages to the appliances or the building and all. So lightning conductor is just a path for the electrons to flow. Let us see how a lightning conductor is working. When the clouds are moving through the sky, due to friction between air and the cloud or between the clouds normally become charged. Let us say about a negatively charged cloud. When a negatively charged cloud is coming near to a building, there the clouds will make the electrons in that building to be repelled and go to the ground so that the top of the building will become positively charged. There will be a force of attraction between the negative charges on the cloud and the positive charges on the top of the building. So there is a chance for the electrons to flow through the air to the building. So that flow of electron through the air to the building is actually producing the spark which we are calling as lightning. That electrons will move through that building and it will damage the electronic appliances in our house. The reason for it is this flow of electron is a large flow of electron, and when this large flow of electron is passing through the appliances will get damaged. So we need to prevent it. To prevent it, if we are providing a path for the electrons other than through the building, then we can prevent it. So what we can do there? We can use a lightning conductor, which will be just a piece of metal which will be placed above the building so that when the electrons are flowing from the cloud to the ground, these electrons will be flowing through that metal to the ground without flowing through the building. So that lightning conductor is actually providing a path for the electrons to flow. In this case, the diagram shown, the charge on the cloud is negative and that lightning conductor is becoming positive. So the electrons are flowing from the cloud to the ground. Now, in another case, if the cloud is positively charged, what will happen? Normally, when the cloud is positively charged, when it comes near to the building, it will attract all the electrons to the top of the building, and the top of the building will have a lot of electrons. The electrons will jump from the building to the cloud. There also a spark is produced. That spark is the lightning. If we are providing a path for that electrons to flow, that is through the lightning conductor, then the electrons will be flowing through the lightning conductor to the cloud and the building will not be affected. Almost all the tall buildings will have the lightning conductor, and if you are noticing it, you can see the lightning conductors on the top of the buildings. Another use of static electricity is preventing fire when we are refilling the fuel in tanks. Normally, when the fuel is passing through the pipes, due to friction, the electrons get accumulated in the fuel and a small spark can explode the tank. In order to prevent that, what we are doing is we will be making the pipe to be earthed so that the electrons will be passing through that earth wire to the ground and the fuel will not get accumulated with the electrons. So we can prevent the fire by that method. The smoke particles and the dust particles which are given out from the chimneys of big factories can pollute the environment. So in order to prevent that pollution due to this smoke and dust particles, we are using electrostatic precipitator. Here also the principle of static electricity is used. There are plates which are positively charged which are connected in the chimney, and there are wire meshes which are connected to negative charge. So when the hot gases and the dust particles move through the wire mesh or the fine wires, it will gain the negative charge, and when it is moving up, it will be collected or it will be attracted by the positively charged plate and get collected there. Like this, we can prevent the movement of these smoke and dust particles to the atmosphere, and we can reduce the atmospheric pollution. The next application of static electricity is spray painting. So here what we are doing is we are connecting the nozzle of the spray painting machine to positive charge and the material to be painted to the negative charge. So when the droplets are coming out of the nozzle, it will gain positive charge and it will spread out. The reason for that is the positive charge and positive charge will repel each other. So the droplets will be spreading out. These positively charged droplets are attracted by the negatively charged object, and the paint is evenly distributed. So we can uniformly paint the material or evenly distribute the paint throughout the surface of the material, as well as we can reduce the wastage of